Welcome to this guide on implementing a reusable object pool manager in Unity, a crucial optimization technique for game development that can dramatically improve your project's performance. Object pooling is a powerful optimization technique that significantly improves performance, especially in games or applications that frequently create and destroy objects, such as bullets, enemies, or particle effects. Instead of constantly instantiating new objects and destroying old ones, object pooling reuses a set of pre-instantiated objects, reducing overhead and garbage collection. The core idea is to maintain a pool of pre-initialized objects ready for immediate use. When an object is needed, it's quickly retrieved from this pool, activated, and utilized. Once no longer required, it's returned to the pool, deactivated, and made available for future reuse, minimizing resource waste. One primary benefit is significantly reduced garbage collection, as pooling minimizes memory allocation and deallocation. This is critical on mobile devices and resource-constrained platforms, where frequent memory operations can cause performance hitches. Object pooling also lowers instantiation costs, as creating new objects can be an expensive CPU operation. By reusing existing instances, pooling avoids these repeated costs, leading to a more efficient and responsive application. Ultimately, reusing objects reduces CPU load and memory pressure, improving overall performance and gameplay experiences. Object pooling is most effective when you frequently create and destroy the same type of object or when their creation is performance-intensive. Common use cases include rapidly spawning entities like bullets, projectiles, enemy characters, and particle effects. Conversely, avoid pooling if objects are created infrequently, if creation is lightweight, or if you have ample memory. Now, let's dive into implementing our reusable Object Pool Manager script in Unity, starting with creating the necessary C# files. First, navigate to your Unity Projects Assets folder, right-click, and select Create, then C# Script. Name this script Object Pool Manager. Next, we'll define an interface called iPoolableObject to ensure all pooled objects adhere to a common contract. This interface will define a single method, void_return_to_pool, requiring objects to provide their own logic for returning to the pool. Now, let's implement the Object Pool Manager class itself, which will orchestrate the entire pooling process. Begin by adding using statements for System, Collections, Generic, Unity Engine, and Unity Engine, Pool. Inside Object Pool Manager, we'll define an inner system, serializable class called Pool to hold configuration details for each object pool. Each pool configuration includes a tag, prefab reference, initial size, and an expandable boolean. Declare a public list, pool pools, for configurations and a public dictionary, string, QGameObject, pool dictionary, for object queues. To ensure only one instance of our Object Pool Manager exists, we'll implement the robust singleton pattern. Declare a public static Object Pool Manager instance, variable to hold the single instance, making it globally accessible. In Awake, if instance is null, assign this to instance, and optionally use don't_destroy_onload. If instance is not null, we destroy to prevent duplicate instances and maintain singleton integrity. The start method initializes our object pools based on inspector configurations. First, initialize pool dictionary as a new dictionary, string, QGameObject, to store object queues. Then, loop through each pool configuration, creating a new QGameObject for its specific objects. Inside this loop, a nested for loop instantiates the specified pool.sizeNumber of pool.prefab objects. Each obj is set to obj.setActive and then object pool, and queue adds it to its queue. Finally, pool dictionary, add, associates the queue with its unique tag. Now, let's create the crucial spawnFromPool method, responsible for retrieving, activating, and positioning objects. First, check if pool dictionary.contains key. If not, log a warning and return null. Next, retrieve an object using GameObject_object_to_spawn equals pool dictionary tag to queue. If the pool is empty and expandable is true, a new object would be instantiated here. The retrieved object to spawn is activated with object_to_spawn.setActive, and its position and rotation are set. We then check if object_to_spawn implements iPoolableObject to potentially reset its state. Crucially, The object is immediately re-enqueued using Pool Dictionary, tag, enqueue for future reuse. Finally, spawn from pool returns the active and correctly positioned object to spawn. Next, we implement the return to pool method, called when an object is no longer needed. Inside, object to return.setActive deactivates the object, making it invisible. Optionally, object to return.transform.setParent can clean up the scene hierarchy. For any object you want to pool, its script must implement the iPoolableObject interface. This means adding public class myPooledObject, monobehavior, iPoolableObject, and implementing return to pool. Within return to pool, you'll call object pool manager, instance.returnToPool. When your pooled object finishes its task, call this return to pool method instead of destroy. After writing scripts, configure object pool manager in the Unity editor to link prefabs to pools. Create an empty game object in the hierarchy. Name it Object Pool Manager. Drag your Object Pool Manager C# script onto this game object in the inspector. In the inspector, expand pools and add elements for each object type you wish to pool. For each pool, specify its tag, drag the prefab, set size, and decide if it's expandable. For instance, configure a bullet pool with your bullet prefab, size 50, and expandable to true. With our Object Pool Manager configured, let's explore best practices for optimal performance. First, always presize your pools to the maximum number of objects needed during peak usage. Initializing with this maximum avoids runtime instantiation, preventing performance spikes, and ensuring smooth gameplay. It's crucial to reset an object state every time it's retrieved from the pool to prevent unexpected behavior. This includes resetting variables, clearing lists, re-enabling components, and resetting physics properties. For complex objects, consider pooling entire hierarchies rather than individual components. Pooling hierarchies simplifies management, ensures all related parts are handled together, and reduces code complexity. Always use the Unity Profiler to measure the actual impact of your pooling system and verify its benefits. The Profiler helps identify bottlenecks, confirm performance improvements, and fine-tune pool sizes. Remember that object pooling trades memory for performance, keeping objects in memory longer. On memory-constrained platforms, balancing pool size and memory usage is crucial to avoid out-of-memory errors. By following these steps and best practices, you can create a robust Object Pool Manager script, an invaluable asset in your Unity projects. This optimization will significantly improve your Unity application's performance, leading to smoother and more enjoyable gameplay. Implementing object pooling is a fundamental skill for any Unity developer building high-performance, scalable applications. Thank you for joining us in this detailed tutorial on creating a reusable object pool manager in Unity. We hope this guide empowers you to enhance your game development skills and optimize your projects for peak performance. Keep building amazing things,